name is John Isaac Marino, and today we're talking about basic pulses in digital communication. Now, first thing first, let me define to you what is pulses. Okay, a pulse in signal processing is a rapid, transient change in the amplitude of a signal from a baseline value to a higher or lower value, followed by a rapid return to the baseline value. Okay, so when we talk about these basic pulses, it will be divided by three. Okay, the type of these three basic pulses is capital NRZ, or no return to zero, and capital RZ, or return to zero, and lastly the Manchester pulse. So now I will explain to you the NRZ pulse, or not return to zero. Okay, here in this figure, first the NRZ, or return to zero. Now when you see this pulse, you will be find that it has a characteristic which has no return to zero, where if we say this, what the time TB here, the time TB, and a unit of a pulses, TB from zero here, TB from zero, and the amplitude is A. Here's the amplitude. Okay, then you'll be finding amplitude will not return to zero. Okay, the entire pulse duration TB, so during the entire pulse duration, amplitude will not return to zero. That's why this is no return to zero. This is one of the type of pulse where the amplitude will remain constant. Okay, then the entire pulse duration, so within TB, pulse will not return to zero, meaning pulse occupies entire bit duration with a fixed amplitude. Okay, so within TB, pulse not return to zero, means pulse occupies the entire bit duration with fixed amplitude. Okay, next, capital RZ, or return to zero. So here pulse occupies half of bit duration. Okay, first, on first topic, the NRZ, it will occupy all bit. Okay, but when it comes to return to zero, the pulse here occupies half of bit duration, so we will have TB over 2. So what is return to zero? Based on our research, in this case, you will be find how bit duration TB, where here has a TB over 2 here, TB over 2, and here is 0, and amplitude A is here at the top. Okay, after half bit duration, pulse will return to 0. So after half bit duration, amplitude will remain, and another half duration amplitude will return to 0. Okay, and the amplitude will remain A. So the half bit duration, it will occupies only the TB over 2. So return to 0, it will occupy only the half bit of duration. Okay, third, the Manchester pulse. So meaning at half of duration, there is transition from high to low, or low to high. Okay, what is that? Okay, and after the Manchester pulse, if we say we have bit duration TB, so here half bit duration, okay, is there TB over 2, here TB over 2, and here time per bit is 0 here. Okay, then in case of Manchester pulse, for half of beat duration, it will be A plus here at the top. Okay, and the next half duration, it will be A minus A. That means there will be a transition from positive A to a negative A during half of that duration. So, meaning at half of duration, there is transition from high to low or low to a high. So that is what is the case of happening in Manchester pulses. Okay, always remember, okay, the difference of the three basic pulses, capital NRC or no return to zero, both pulses occupies amplitude for the entire beat duration. It will not return to zero. Okay, when it comes to return to zero, the case is the half beat duration. No, it will be occupied by pulse and another half will be returning to zero. And lastly, in the Manchester pulse, the half of beat duration, there this is beat high, then there will be transition for another half duration. It will go to negative A. That is how Manchester pulses work. And now, let's proceed to basic pulse shaping technique were generally used in digital communication, which is unipolar, polar, and bipolar. And now, let's proceed to basic pulse shaping technique were generally in using digital communication, which are the unipolar, polar, and bipolar. First is unipolar pulse shaping technique. Usually, we assign voltage level with respect to bits. So here in the PowerPoint, there's a bits and level. So when we have bits 1 and 0, then 1 is assigned with voltage, which is positive A, and 0 is assigned with voltage 0. This positive A voltage, it could be a positive 1 voltage, or it could be positive 5 voltage, or it could be positive 10 voltage, and positive 20 voltage. And 0, that is also assigned with 0 voltage. So, that is what we're doing in terms of voltage assigning in unipolar techniques. Now, when we do polar, what we do is assign bits with voltage level as per 1 and 0 is assigned with positive voltage and 0 that is assigned with negative voltage. This is what the case in polar. And lastly, now in bipolar pulse shaping technique, what we do here is assign bits with voltage levels where 1 is assigned with positive A, negative A, and 0 voltage. The 0 is assigned with another 0 voltage. So when you observe here, there are basically three different voltage levels, the positive A, the negative A, and 0. And because of these three different amplitude levels that is assigned by bipolar, it is referred that we should do in pseudo ternary code, where the word ternary means 3. Where here, we are assigning 3 voltages in terms of zeros and ones. That is why it refers to as pseudo ternary code. But we need to understand that this positive A and negative A that we were assigning is alternating. So here in the PowerPoint is the example of bipolar. If we send 111 or 1, 1 and 1, so here the PowerPoint, that's the 111. This is the waveform that we can generate. So here, where here with respect to time, and here is the amplitude. So let this positive A voltage, and here is negative A voltage when we send signal by using bipolar. First one, there is assigned with a positive voltage, but when it comes to the next one, the time in this voltage will get alternate. So next, one will be assigned with voltage that is negative A voltage. And when it comes again to the next one, it will be signed again with positive voltage. So one thing that we can understand here, we need to have memory of one bit, where it needs to remember a voltage which was there with previous one. So bit 1 is marked as positive and negative A alternating. And this method of bipolar is referred as alternate mark inversion code, or AMI code. So this is what the basic pulses shaping technique is all about. Thank you so much, and I hope you learned in this topic.